Thanks everybody, and thanks to Josh and Dylan for having us. My name's John. I'm the VP of Data at Scopely. Everything we're going to talk today is somewhat relevant to Scopely, but is formed on the basis of experience of multiple companies over a number of years. I've been working with Looker in one way or another since I think 2016. That's kind of 3 companies in that time from King, GoCardless in the UK, and then Scopely here in Barcelona. And I'm joined by Tiago, who runs our BI platform team, who is the real brains behind what I'm going to present. I could be the face, Tiago could be the brains, and when we get to the technical questions, he will take over. This we're going to talk you through. Rereading the name of the presentation, it's a wordy one, which is not unusual for me. I think another way we could name this presentation is, raising your Looker instance child from messy toddler to sophisticated adult. And so what we're going to do is we're going to set the scene, and then talk about how things started to go with our Looker journey. And 2 phases of optimization on our instance to get it to where we wanted it to be, and then a little quick bit at the end about the future. So let's crack on with the scene setting. So you'll hear me talking about Playgamy a lot. First, an introduction to what Playgamy is. Playgamy is the technical platform for game publishing, fundamentally. So whether it's from an analytics perspective or a CRM perspective or an ads and user acquisition management perspective, pretty much anything you need to publish a game from end to end is covered by the Playgamy platform. And the main output, Playgamy covers a whole range of things, but the most kind of visible output, let's say, is an application called the Playgamy Console, which we shall talk a little bit more about in the future. So within the Playgamy, you can do a whole variety of things. So you can run A/B tests, experiments on your game. You can analyze winning variants and the impact on the product, and then ultimately, pick that and inform certain things about how you take product direction and features in the games. There's a whole bunch of predictive machine learning capabilities that enable you to do things like detect spend slowdown, and churn probability, and not just diagnose who may be churning in your game, but ultimately the reasons that may be driving that churn. So maybe we're showing too many ads to a certain cohort in user, or maybe there's another cohort that experience particular high technical issues, rates of technical issues. So you can understand what's driving the probability of churn. You can understand who, and you can take certain actions on that basis as well. So a key part, like we call the sort of atomic unit of Playgamy is the segment, and whether it's a prescriptive segment, people who have reached a certain level at a certain point in time, or people who are stuck at a certain point, or people who have bought a certain bundle. We have our prescriptive segments, and we have predictive segments as well. For example, those who are high propensity of churning. And then based on those segments, game teams can take a whole variety of actions. So they can send push notifications, they can send email content, they can interact with other CRM tools, and take decisions and act on them accordingly through the player journey. We also, of course, at the heart of this, data is the lifeblood of the whole thing. So the analytics journey is well captured within the Playgamy Console as well, starting with the description of your tracking plans, your telemetry in your game, what events you want to fire, what fields and what values you want within that event, through to the classical use case where I need to see period over period comparisons of how cohorts are doing and how game KPIs are performing over time. Away from the sort of the marketing images and speak, in a more concrete level, how does this overlap and how does this relate to Looker? Well, as I said, sort of data is the lifeblood of Playgamy Console, whether it's about predictive segmentation, or whether it's about push notifications, or whether it's analytics, one way or another. It's within my team's domain to make sure this works well. And to do this, we use a combination of tooling, dbt, BigQuery, and Looker. But here today, we're talking about Looker, and specifically the different ways we use Looker within Playgami, and the way that that's impacted how that's scaled over time. So firstly, we have our sort of classical embedded use case. So within the Playgamy console, which you see here, we have the dashboards that we're embedding wholesale into the Playgami in Playgamy Console. And so, this use case here, just a classic dashboard with a fake game that enables to see common KPIs, how they're changing over time. And there's a multitude of these and a multitude of insights that are available to the users. Then this is another one of those examples where we have intraday insights. So we're able to play back in near real time predictions of how the day is going to go, and the users can assess this at any point in the day and take action accordingly, how revenue is going, how error rates are going, how offers are working, and so on. And again, this is sort of a full dashboard embedded into the Playgamy console. Then we have the next level beneath that, I would say, which is where we're either embedding just individual looks, or we're leveraging the Looker API. Fundamentally, there's a lot of insight in the Playgamy console. We want to make sure, like good Looker citizens, that data is semantically correct. So pretty much any metric you see relative to any feature in the Playgamy console is more often than not has come by Looker in one way or another, directly or indirectly. So in this example here, within one of our predictive capabilities, you've got in the center here just a standalone embedded look. But these numbers you're seeing around the number of users at risk of churn, the prediction quality, and so on, these are all coming via the Looker API as well. And we're surfacing them in different ways, depending on different user experiences and different features that we're trying to power. And we have, a more traditional native Looker use case as well. So this is going beyond anything that's kind of console, which is, Playgamy console, which is more generic, where game teams want to get really much deeper into much more specialized analysis within their games. That's why we have our native Looker instance as well. And this being a classic example of the kind of things that they're looking at. Beyond that, we also have the non-console API use cases. So we've got 4 key categories of these. The first is user management. So we do a variety of things. So when a user signs up, we're able to gather certain information about who that user is and assign them to certain permissions, groups, and so on in an automatic way. And then add some nice touches like sending them an automated email to welcome them to Looker, to point them in the direction of useful materials, but also if we need additional information from them, sort of point them in the direction of where they can give that to us. So we can manage that all nicely. We do data group triggers. So if you're familiar with the Looker architecture, data groups are a good way to trigger schedules in an automated way, to clear cache and preheat cache and so on, and make sure your data is fresh as possible when upstream events have run. Well, we do that as well. So we use Google Cloud Composer, and we have an operator in there that enables us to hit the Looker API and blow out cache and so on, and trigger certain actions when our upstream models are ready. We also have access restriction checks. So, as part of our privacy and security obligations, we're regularly checking in and screening things to make sure that, that nothing's getting out of hand, that the right people have access to the right things, but we're fundamentally fulfilling the principle of least privilege. And we have a query management aspect to this as well. So what we're doing here is we're screening all the queries that are running on our Looker instance, and where we see kind of bad behavior, for example, a query that's running like an unhealthy amount of time, we will kill that automatically via the API and trigger an email to the user with a link to the query and the content saying, hey, you need to check this out and do something about why it's performing so badly, so that we can maintain a sort of baseline standard of health on the instance. And in terms of the history of our Looker implementation, we began our rollout back in sort of January, February 2020, just before the start of the pandemic. And we've had pretty steady user growth now, up to about 2,000 users, which covers a pretty large majority of the company one way or another. And in addition to the user growth, project growth has been pretty proportional to that. So peaking at around 50 odd queries. And you'll notice this chart on the left-hand side where the projects actually finishes in January. There's a reason for that because, as we'll get to the punchline of my presentation, this is where we started to change our architecture. But, as with these projects growing and these users growing, the overall load on our instance, the complexity and the variety of things we've had to think about has grown significantly. And over that time, we don't have the full history of how query volumes have grown over time, but you can see, around about the start of this year, we're peaking around 250,000 queries a week from a mixture of, direct from data warehouse and from cache. And interestingly, over that time, we've had a pretty consistent trend where we've been trying to drive down query durations further and further. So we have a kind of a crude proxy of 30 seconds or under. Average query duration indicates reasonable looker experience. In reality, the distribution is very different. The vast majority of our queries run in sort of 5 seconds or less, but we use that average as an overall proxy for how things are going. And we want to keep the query numbers going up and that query duration going down. So overall, we started a looker rollout. The adoption has been great. More and more use cases being layered on top, more and more teams engaging and wanting to leverage our data stack in one way or another. But it turns out all is not well. What was not well? Well, fundamentally, as these things became more complex, more workloads, and so on, that ultimately the user experience was not good. Things were performing badly in various different places, and that was having various different consequences. So we decided to embark on a journey of optimization. And in reality, I don't think optimization ever ends, but we've had two very specific pushes over the course of the last year to get things to the place where, having gone from that sort of toddler and that adolescent in the looker sense of going, okay, we're starting to work out how to use this tool. We're starting to work out how this business needs to use it and how it relates to complex use cases like the Playgamy Console. Now we understand, now we know enough to go into the outside world and think about what we would do differently and think about what we need to refocus on. So that first phase of optimization consisted of two different focuses. The first one was the obvious one, I think, was around query performance. Anyone who's worked with Looker for any period of time will know that, fundamentally that your Looker content, your Looker instance health is only really as good as the data model it's sitting on top of. And when that's not going well, nothing else goes well. So first we wanted to make sure that we were not making any obvious mistakes in terms of the underlying health of our data model and explore architecture. And then we wanted to focus on instant hygiene and make sure that it was clean as possible, that there were no obvious problems in the way that we'd set the content and so on of our instance. So in terms of the query optimization, I'm not going to go deep into that today. But we invested a lot of time across our core data teams and working with some of our, we work in a hub and spoke model, so some of our game teams making sure they were focusing on this as well, to make sure that there are no obvious mistakes, that we're really thinking about the scalability of our data models. And what you see here on this slide is an example of one of our marquee products that we released last year. It's the same as the one you saw earlier with the live insight, those intraday analytics that enable game teams to understand gameplay, engagement, and monetization in near real time during the course of a business day. Those products replaced an actual real-time product that was built many moons ago at Scopely. And we decided not to go down the real-time path. We decided we valued the semantic layer and the sort of computational muscle of BigQuery and micro batch ETL and so on, much more than we did data being fast. So we wanted the data to be relatively fresh and really accurate rather than not that accurate and really, really fresh. But the problem was our users, they were looking at this content and going, well, this is really slow. Not only is it not real time, so they're measuring against that as a baseline. And when they ran these dashboards or we auto ran them, they would take a very long time to load. So we had some pretty unsatisfied users who, as we started to move them across this tool. So we spent a lot of time kind of iterating on how these tools were architected, working out the balance between Looker workload, BigQuery workload, and so on, and what the trade-offs are. And you can see here in the chart that there's been incremental improvement, but there was a really big step change at the beginning of this year, around January, February time, where we made some particular breakthroughs. So now we've got sort of query durations, the runtime of the dashboards under 10 seconds consistently. We're not having quite the same variability at peaks. And the results, well, fundamentally in the yellow series here is an example, a big uptick in product utilization, not just in the number of users who are using the product, but also the amount that they were able to drill and explore and get a lot more value than they got. And now we've crossed the line of being able to do what we used to do, but better, as in we're better than the real-time product that it replaced. So that's a kind of key example of how we've been able to make some breakthroughs in that area. As a quick aside, I think at various points when I've been working with Looker, there's things that I've wanted to. One strategy that I've regularly deployed is thinking about cache, using data groups, as I talked about before, via the API, making sure preheating cache as much as possible so that the first user of the day is not the one who pays the price of that first query load, just to make sure that first impressions really count in my experience. And so when we were building a lot of these console products for Playgami, we were doing a lot in terms of triggering the build of certain dashboards, preheating the cache a lot across a lot of dimensional combinations to make sure that things were really fast. But actually, we learned something important here, which was that doesn't actually always work. We were putting a lot of strain both on BigQuery and on the Looker instance by doing that. So we're essentially just moving the point of the problem rather than really solving the underlying problem. And actually, there was a lot of waste. In reality, a lot of those dimensional combinations were not reused by the users. So we were very happy to, once we realized that, to have the epiphany that we could dial this down, stop preheating cache so much, focus on optimization. And actually, the results are that things have got quicker and we're running fewer queries. So overall, it was a kind of a turn of events, but one where we learned an important lesson. So that's around the sort of query optimization. Once we started, in addition to and in parallel to that work, we're also working on the instance cleanup. So we did this in 3 particular ways. So first, we focus on oversized dashboards. I think it's like Looker's default response when you say, hey, my instance is not performing well. They say, well, how many dashboards have you got with more than 25 tiles? So Tiago and team spun up some content to alert users to where they had oversized dashboards, or to help explain where they needed to focus and direct people's efforts. And then we helped them through education to redesign the dashboards so they were lighter. We focused a lot on project complexity, so reducing the number of files in our LookML projects, and making sure that the way that they were structured was as rational as possible to make sure that when we're doing LookML content validation, sorry, not content validation, when we're doing project validation, that is as lean and efficient as possible. And we removed a lot of inactive content using the Henry tool, which, if you're not familiar with it, you can find it's an open source tool which enables you to automate a lot of the archiving of legacy products, the content that's no longer active. So overall, things were a lot better, and I think we dealt with a lot of the low-hanging fruit. We'd really improved the engagement with a lot of our products. We were getting good dividends, but we were certainly not out of the woods yet. We were still seeing problems that meant that we needed to go a little bit further. And here's a little video that Tiago made last year that illustrates the scale of this problem. So what you're seeing here is the Playgamy Console that I showed you before. And this is one of those main portfolio dashboards that we have. And this is what the user experience looked like. So we've got, what, an 18-second clip here. I'll play it again. And you can see for, I think, what is it, at least the first 15 seconds of that, nothing is happening except for this kind of spinning wheel. So what this is doing is, this is the point where console contacts Looker and waits for Looker to do something. And then eventually it kicks in and starts to render on screen. So we started to realize, hold on, this is bigger problem than just query durations. The Looker instance itself is struggling, and it's really struggling to return and render content at the speed we needed to. So it doesn't matter how much we optimize our queries, we're still going to see a poor experience for the user. So then we had to focus on the next level of optimization. What were the reasons for us to do that? So first is to say that the console and LookML performance was poor before any queries even ran, which was a clear sign that there was a problem. We were starting to have unhappy users and unhappy developers. Although we'd improved things in a lot of areas, neither of those two groups were really satisfied with how productive they were able to be in their day-to-day for one reason or another. We could see that LookML validation was increasingly CPU heavy. We continued on the same track. We were just going to end up getting worse and worse. And fundamentally, the issue with having queries being triggered by people developing and queries being triggered by business users just using production content is a world when nobody wins. It's the worst of both worlds with those two sets of people. Sort of even with the computational muscle of BigQuery and a well-provisioned Looker instance, fundamentally the concurrency was still such that people were essentially fighting over those concurrent slots. So what to do? So we thought about it and we realized as far as we could tell, we had two options. The first one was just to go and ask Google/Looker to increase our instance size. We'd been there before and it worked reasonably well in the past. Second option was to go from a single instance to a multi-instance setup on Looker. So when we were looking into this, we broke it down into the pros and cons. The first one on just upsizing the instance, well, obviously it was, in theory, it was quick and easy. And importantly, is no cost increase. So we're just going to ask to have what we've already got, but bigger. We've done that before. On the cons, we were realistic. We knew this was a kind of short-term solution and that we were just going to hit a scaling problem again in the future. That's exactly what had happened before. We also had a doubt about what if Google said no. There's a limit to how far they'll go with these things, and each time, they're being more and more vocal about how we need to focus on best practices and so on. So we could exhaust their patience. And realistically, we knew it didn't really tackle the root cause. Option two had the advantage that, well, it did tackle the root cause, or at least believed it would. And we knew we'd be following more best practice recommendations in terms of architecture and development workflows. We would have a clear separation of concerns between development workloads and production workloads. And fundamentally, this would be a project that was in our control. If we decided to do it, we could do it. We wouldn't be dependent on the goodwill and turnaround time of Google. On the cons, this could be expensive. If you have a Looker contract that is not already set up for multi-instances, then you may well have to put your hand in your pocket and pay for another instance, and that can be a cost prohibitive. In our case, we were lucky. We already had a contract that covered multi-instance. We just hadn't had the reason to leverage it, so in that we could cross this con off. But fundamentally, this did require a real re-architecture, a radical rethinking of how our Looker setup would work. That would be hugely disruptive to our developers, not so much to our business users, and it would require a lot of developer education. So they'd have to pause, they'd have to stop what they were doing, they would have to learn how to do it again in a different way, and that would affect their productivity, their efficiency. And fundamentally, this is a big project. It's a lot of work that we're going to have to do. But the winner was the multi-instance setup. Sense prevailed, and we decided to do the hard yards and do the harder work to get something that was much more future-proof. So how do we do this? The first thing is pick up the phone, ask Google, get them to spin up that dev instance that we had under our contract. And then we had to think about how we kept that dev and production world in sync, because fundamentally we need that to happen so that we could develop in one place and move to another. So the first thing we worked on is the content syncing mechanism. By content, I'm talking here about looks, dashboards, tiles. If you do something on dev, how do you get it to prod? If you do something on prod, how do you get it to dev? Thirdly, we had to think about the LookML syncing mechanism. In reality, we already sort of had this out of the box because that's fundamentally what GitHub enables you to do. But nevertheless, we had to think about how we were going to leverage that and what good looked like in that world. Number 4, we had to sync the instances baseline. So having dealt with the mechanisms, then we had to make sure those 2 instances were starting at the same point. And then we had to segregate our dev users, remove them from production and put them onto development and make sure nobody was able to develop on production ever again. But with that all done, we could roll out and get people working. So the architecture that we designed, in simple terms, it's just 2 instances, but there were some subtle points that we had to make sure that these were the sort of laws that we first and foremost, LookML development should not be possible on the production instance, and no one has development rights on production in any capacity. Content development should be possible on the production instance and the development instance. There are plenty of business users who don't need to write LookML, who are still exploring, building their own looks and dashboards. They needed to carry on being able to do that. And we needed to be able to reflect that on the development instance. And we need to be able to change things on the development instance and push it back to production. That needed to be really easy. So syncing the 2 things should be very simple. Otherwise, we could get really in a twist. Computationally heavy workloads should no longer happen on the production instance. So LookML validation, that needed to be isolated and locked down just onto the development instance. So essentially, developers could hurt developers, production business users could hurt production business users, but the 2 couldn't hurt one another. And then we need to separate those dev query workloads from business user queries so that they're not competing with each other for concurrent slots. So with that architecture in mind, and with the need to sort of get this syncing components up and running, what Tiago and the team developed was something called the Looker Bridge. This is what takes care of syncing content from one side to another. Under the hood, what this is a Google Sheet that enables you to describe what it is you want to move and where you want to move it to in simple terms. And that's shown here in the table at the bottom. So in this example, you can see where Tiago has been saying, hey, I need to move some things from production to development. It's a dashboard I want to move. This is the ID. This is what it's going to be called. This is where you're going to get it from and send it to. And then we're going to play back as the bridge runs the outcome. So did it pass or fail? If it failed, why did it fail? When did it run? And so on, so that developers can use this for diagnosis. So once you define what's in that config, what's actually running is a Python script. That Python script, what it's doing is it's connecting to the APIs of the 2 environments, development and production. And fundamentally, importantly, it's authenticating as the user who wants to do that syncing. And we do this to ensure that the rights at the destination are appropriate for what they're trying to do. So what we don't want anyone to do is use this as a backdoor to upload content to a destination where they shouldn't have access rights. What this Python script is doing is leveraging a tool called Gazer. This is an open source tool that you can find that enables to do multi-instance content syncing. So we didn't have to build that from scratch. And it just fundamentally takes care of the push and the pull mechanic. And just to re-emphasize, this is bi-directional. You can go from dev to prod, from prod to dev. And all of this is then encapsulated in the Docker image, which is being run every 10 minutes via Google Cloud Composer. So all the user has to do, enter the details of what they want to move, and then max 10 minutes, they'll see that at the destination. So then from the LookML side of things, how does that work? So we have the sort of LookML component, we have a linting component to this too. So fundamentally, the LookML movement leverages, basic GitHub workflow. Users will work in their personal branch. They will push to the development branch. The development branch is essentially what you call production mode on the development instance. And then from there, they can push from production to the master branch, from development to the master branch on production. And this is all done via a webhook. On this flow, what we're also doing is we've implemented basic LookML linting. But doing this, we're using a tool called Look at Me Sideways, or LAMS. And this is triggered by GitHub actions. Now that linting, what it's doing is it's checking for best practices. It's checking that certain rules, conventions are being followed, so we can ensure a certain level of hygiene and standard within our LookML code. What you can do is you can fail builds, but right now we're only raising warnings. This is a relatively recent thing that we rolled out, so we want to give our users, the developers, the time to adjust to this new dynamic before we start giving them the sort of hard slap on the wrist. So in terms of what this looks like, this architectural overview should help explain it. That what you have in the verticals here is our two instances, development and production. What you have in the horizontals is the technologies, Looker and GitHub. So from a LookML syncing point of view, the users developing, the users with dark blue here, the ones with development rights, they're working, they've got their LookML, they're also adjusting content accordingly that's been affected, and testing. And then when they're ready, they open a pull request, LAMS is triggered, and in the development branch, you will have your code. And you can, if you've got some warnings you want to work on, go back, do it again. But fundamentally, you've got that code into the development branch. When you're ready, you then open the pull request to get to the master branch via that webhook. And there you go. You've got your LookML changes available in production. Then on the content side of things, you could be working in either of these two worlds, development or production. And the Looker bridge will enable you to sync content back and forth as and when you need. And business users, the orange ones here, can continue to be working away. And LookML developers who don't have development mode in production, development rights in production, can be working here and syncing back and forth. And we have this kind of virtuous circle as these can go back and forth between these worlds. And it's working pretty well. So the end result here is that we've got happy developers and users. We were a little anxious about the impact on the developers in particular, but the adaptation has been pretty seamless. We have, I think, responded well to their feedback as we rolled this out. So we've made sure it's not overly prescriptive and responded to what their concerns were. Fundamentally, we've got a much improved instance performance now. Things, whether you're a business user working natively or a developer, the productivity you have is significantly improved. Faster queries plus faster instant performance fundamentally means better product adoption and utilization. So, those developers' work is getting more value, and ultimately our Looker investment, the higher ROI. And it's also helped us understand where anywhere we continue to have issues, it's much easier to triage now and understand really where the root of the problem is. Is it in the data model? Is it in the Explorer architecture? Is it fundamentally Looker itself? It's much easier to separate these things now in terms of how we break them down. And as a bonus, we've got improved development standards. Our developers are increasingly, the best practices are built in and habitual. So what comes next? So as I mentioned, the Looker bridge is running on a sequential basis every 10 minutes at the moment, but in the future, we'd like to get to the point when you open that pull request to push to the master branch on production, the bridge automatically kicks in as well, and content can be taken within. The Henry tool that we utilize for cleaning up the instance, and I think we've cleaned up somewhere in the region of 10,000 assets, so the looks or dashboards up till now. We want that to be fully automated. Right now, Tiago and team are just running that on an occasional basis as and when we feel it, but we want that to be something that's fully happening on a continual basis. On the linting side of things, as I mentioned, we just raise warnings right now about code standards, but in the future, we'll start actively failing the builds and raising the code standards and governance level, that level higher. And then finally, this is somewhat contradicts almost everything I've just been presenting on, but the benefit of being able to more clearly diagnose where the problems are in terms of performance has made us realize fundamentally where the limitations are of what we can expect Looker to do in embedded content. So what we're building, or what the Playgamy Console team has built, is something called the metrics catalog. And this essentially is a service that gathers information via the Looker API and places it in cache close to the console, so that you're not waiting for any Looker overhead at all during the Looker user session in the Playgamy Console. Fundamentally, what we've seen is there are certain places, for example, in those churn prediction screenshots I was showing you earlier, where there are places where even a fast looker experience is not fast enough for what we want the user to be able to do. So this metrics catalog still grabs information by the Looker API to make sure that it's semantically correct, but it does that elsewhere ahead of time and then places that information so that it's instant experience for the user. So there's still a win, it's still accurate, and it's good to go. And that is that. Thank you very much.
Awesome. Jon, thank you very much. That was really, really interesting. We've got, I think, a couple minutes for Q&A. So we've got a bunch of questions in Slack. If you have others that you'd like to ask for any attendees, please head over to Slack to ask them. But we're just going to jump right in. One from, I believe, a former colleague of yours, Ian Thompson. The question was to whether you could reiterate the main issue that led to multi-instance, and specifically around kind of the validation piece. I think the question is like, when exactly were you hitting that LookML validation that was causing such a performance strain on the Looker instance that you alluded to earlier? Was that just as part of the development process?
Yeah, Tiago, correct me if I'm wrong, but we've got a significant number of developers. They're developing on Looker models all day long, and as not only the number of projects increased, but the size and complexity of those projects increased. Bearing in mind that a lot of people who built those projects in the early days were not Looker experts. It was their first experience. When you go and actually hit the validate LookML, that could be very computationally heavy and happening throughout the business day. So it was we could see through working with Looker the big CPU spikes that were happening when that was happening. Is that a fair description, Tiago?
Exactly. I was going to tell you exactly that. We noticed that when the developers were using the production instance, they were creating like spikes of the CPU usage and memory usage when they were validating the code in the development mode. And also another thing that we noticed is when they were running some tests using the explorers they were building or the dashboards, they were creating like queues in the queries page with in the connections they were using. And that's why we decided to modify this and move these developers to a new instance to make this, remove this weight from the developments from the production instance and give the user the best user experience possible with the instance we have.
Awesome. I've got a question from Emmanuel here, who says, if I understand your diagram well, pushing changes live on dev automatically pulls them into the production instance. If so, what's the difference between that and a normal instance in terms of the dev process? How do you manage the deployment manager in that context? So I think the question is, you talked about kind of merging into the deployment branch, which was production in the development instance, and then also merging into kind of master, which is production on the prod instance. I guess, can you just reiterate how that flow works and when the actual deployment to the prod instance happens as part of the pull request process?
Yes, I can answer that one. Right now, as we have defined it, we have two main branches in our GitHub repositories for each project. One is the develop, that it's the main branch for the development instance. And when you do the pull request from your personal development branch or from the shared branch to this branch, it's deployed on the development instance. Okay. All the developers, they are able to test all the developments they did on the development instance, change the dashboards if they need, do everything they need on this instance. And when they feel comfortable, they just need to go to GitHub and do a merge request, a PR from the develop branch to the master branch. And when this PR passes with the checks that we have, when they merge the code to the master branch, that's where the code is released to production. So they still have this development instance to test all the developments before they go to production.
And I'm jumping around the questions a little here just to group them because they can be relevant as a follow-up to that. So did you think about using Looker Deployment Manager, which allows you to kind of deploy specific commits or tags using advanced deploy mode instead of that? Or how did you decide that I guess, personal branch to development branch to production branch was the right flow for you in the organization?
Yeah, in this case, we did some tests with the deployment manager and everything, but we opted in by this version because we had already some similar processes running in other parts of the company, and that's why we decided to opt in for this kind of version of deployment, because it was something that it was already known by all the LookML developers. We didn't want to disrupt too much the life of them, and we opted in to take this decision of going following the same process that we already had in other parts of the company to deploy things to production.
Makes sense. We're probably got a couple minutes, so let me try a couple more questions. Do you think if it hadn't been, we talked earlier in the Q&A about the validation performance issues that hit production when people were developing there. Do you think even if that wasn't the case, so if you had all your other issues, but you hadn't had those LookML validation performance issues, do you think the benefits of the multi-instance setup would have still pushed you in that direction eventually?
Yeah. In my perspective, having this multi-instance architecture, it's a benefit for all the developers because they are able to test everything they do before they send things to production, and we have the power as developers to not expose the users to any kind of wrong things that we may do or incorrect content that we didn't want to share. So we had here a good opportunity to also give more power to the developers and a better user experience for the users. And with that in mind, we opted in to take this decision. I believe even we thought this already even before we started to have issues. That's why I believe in our contract, as Jon mentioned, it was already a multi-instance contract predefined.
Yeah, and just to add, though we didn't go into it today, in terms of how our projects and the permissions associated on the BigQuery level, we have a very clear separation between dev and production there as well. And the single instance setup on the Looker side made it very hard to set up service accounts and permissions in a way that you could get the best of those worlds. So actually our developers, whilst there was some disruption, they were very happy that we separated because it then meant that they could get more direct access to the dev data sets from in a secure way.
I'm going to ask one last question, which is, you talked about using Looker Bridge to move content between the two. And it sounds like, as I understand it, you kind of have to go in there and kind of highlight the specific pieces of content to be moved from one to the other. Is that right?
Yes, that is correct.
Perfect. And so I think the question that someone was asking was how, to do that, the developers have to be aware of the content that they want to migrate. Presumably there's a bunch of content in production that non-data practitioner, people not in your team have created, and you want to make sure you don't break, I guess, mostly from a content validation point of view when they're developing in dev. How do you ensure that you're not removing dimensions or things like that someone is using in prod but isn't being used in any of the content that's been synced with dev?
So just to make a disclaimer, we took the decision to not pass the full content that we have on our production instance because we have more than 2,000 dashboards and I don't know how many looks, and that falls in there. It was not possible to do this full migration from all the dashboards from one instance to the other, but we needed to give the developers the opportunity to develop in one instance and take what they develop for the production instance. The users itself, they don't have this power to move content from one instance to the other. They have that restraint because they don't have access to the development instance. Okay, and due to that, and since we are using the Looker API to check if the user has permissions to move the content for the specific folder they want, the users, they don't have an user on the development instance, so they are not able to do it. But yeah, we thought about passing the full content of dashboards and loops from one instance to the other, but we saw that if we do that, it was a huge, it was a long way to go to move all this content in the best way. And we opted in for not doing, but giving the developers the opportunity to do it as they want.
Yeah, that makes a ton of sense. Awesome. I appreciate we've got some more questions, but I'm going to have to call it there. Jon and Tiago are in the Slack channel. They're obviously not looking at it right now while they're on the webinar, but they may be able to pop in after or tomorrow and have a go at some of the other questions that I haven't been able to get to. Apologies to everyone for not being able to get to all of them. That is it for today. As I talked about earlier, we've got these webinars every 2 weeks. In 2 weeks' time, we'll be working with the team at Metaplane to talk about how you kind of justify data quality and ROI on data quality initiatives. And so I hope to see many of you there. You can head to spectacles.dev/webinars to find those. But before we leave today, Jon and Tiago, big thank you from us and the team at Spectacles. This has been super insightful. Really appreciate you taking the time to do this. And I'm sure we'll try to have you on again sometime in the future.
Thanks very much.
Thank you. Thank you.